The third type of P&IDs is related to the distribution P&IDs. Here we are talking about the arrangement of utilities and effluent headers and how they are distributed in the whole plant. Among other examples are the P&IDs for the cooling water supply header, cooling water return headers, and instrument air header, relief header, closed and open drain headers. In these P&IDs, utility users or effluent sources are laid out geographically to preserve all elements, sequencing, and relative locations. So let's take the cooling water supply as an example. We have multiple water coolers across the plant, so we need to show how the cooling water header adjusts the distribution of the cooling water lines. This makes it easier to predict the system hydraulics. However, the details of each user are shown on the main P&IDs. So the isolation valves serving the cooling water line on the cooler or the relief line on the PSV are not shown on the distribution P&IDs, but rather in the main P&IDs. Distribution P&IDs usually don't show valves or instruments except the ones related to the header itself. This can be applied to represent the distribution precisely. Another example can be seen in the relief distribution header. We need to analyze the back pressure of each PSV during different relief scenarios. If the back pressure was found to be too high, then in this case, we need to change the arrangement of the header. Otherwise, the PSV may not function properly, which shall lead to an overpressure in the vessels that they are protecting. Or if this is a flare header, when the PSV opens or the plant is depressurized, the fluid goes through the relief header and finally to the flare. So, to represent the distribution of utility and effluent headers precisely, it's a common practice to show them geographically with the exact directions in the plot plan.